In this demonstration, we're going to create a response surface design and then look to see how we can construct and interpret the associated response surface. So first I'm going to come to the DOE menu, and from here I'll select response surface design. By default I have a single response and I have two factors. You'll notice also the response has a goal associated with it. The goal describes what we're trying to do with this response surface, whether we want to identify a maximum on it, a minimum, or maybe some target value. I'm just going to leave the maximum for now and leave all the other defaults. So I click continue, and I'm going to take the default design, which is a central composite design. Again, I'll take the defaults and I'm going to make a table. So here is my response surface design. What I need now is some response data. I can create this data through simulation. So now I have some response data. To analyze the data, I come to the model script, which I run. This takes me to the model specification, and you'll note that the model includes second order terms, quadratic terms for x1 and x2. Those represent the curvature of the response surface. To fit the model, I select Run. Okay, so now we're in Fit Model. We're going to look at how we can investigate the response surface associated with this model. From the response hotspots, I can go to the profiler. If I choose Factor Profiler, then there's a surface profiler. This surface is the response surface. I can click and drag to rotate the response surface to get a sense of the overall shape. This surface has been described by a formula. What I'm going to do is save that formula to the data table and go into another profiler which gives me more control in terms of the overall appearance of this surface. So I'm going to come back to the response hotspot and I'm going to save a column which is the prediction formula. Now let me return to the data table. You can see in the data table we have a prediction formula column, and I can use that column to generate a surface by coming to Graph and selecting Surface Plot. So in this dialog I will choose the prediction formula, and I get output very similar to what I had in the Fit Model output, but I have more control in the visual presentation of this surface. You'll notice at the bottom we have a key. The key indicates that the prediction formula is being shown in green. If I click on this green panel, then I have options for how I want the surface to be presented, which colours I want to use, and instead of using a single solid colour, I'm going to choose discrete gradients, and I'm going to select a colour scheme, and I'll choose spectral and say that I want to have 20 levels for this gradient. I'll also put a mesh on, and that mesh just helps visualize. So if I click OK now, here's the surface. We have the colour scheme showing the contours through the different colours, and the mesh to give you a sense of the shape of that surface. And I can click and rotate to get a sense of what the surface looks like. Another way of looking at this surface would be to represent it as a contour plot. Those colours that I'm using effectively are showing me contours of equal value of the response across different values of x and y. I could, from the data table, come to Graph and choose a contour plot option. This option is also available in the Fit Model, and it's fully featured, so let's just look at the option within here. So if I come to the response hotspot and go to Factor Profiling, I can choose the contour profiler. So here's the contour profiler. It may not look exactly what you would expect for a contour plot because we just have a single contour plot. What we'd really like to see are contours across that design space for different settings of x1 and x2. From the hotspot I can choose to put a contour grid on. Now it makes sense with this specification to use some more round numbers here. So for the increment, instead of 207, I'm going to, let's say, 200, and this goes from 2269, so let's round that down and say 2200, and the low, let's make that 600, and we click OK, and now I have my contours. Against the contours we have little dots. Those indicate the direction of the contour, so it shows the upward direction. If you want to take those dots off, you can. They're referred to as up dots. We can just remove those, and now I have the contour. This crosshair is something that we can move with the mouse, and you will notice as I move it, we can read both the current Y value, the response value, and also the current X value for X1 and X2. The radio buttons allow me to assign X1 and X2 to the axes. If we had a third factor, then we could choose which two out of the three factors would be assigned to the axes, and the third factor would have to be fixed, and we could specify the value that it's fixed at. We can also define exclusion regions, which is particularly useful if we have more than one surface, more than one response being shown on the single contour plot. So for example, I could exclude values which are less than 1500, and it shows the exclusion with shading. So the valid region, if I'm looking for a response which is greater than 1500, the valid region is being shown in white. Another way to look at this surface would be to take a cross section through these contours, and that cross section is what the profiler gives us, the default profiler that we see when we come into Fit Model. So if we come up, this profile is being shown by default when we come into Fit Model, and it shows me for a particular value of X1 what the shape is for X2. And if I wanted to look at the shape for different values of X1, I can just drag the cursor across. So we're taking a cross section through the surface. For a particular value of X1, I can look to see what the shape is for X2, and vice versa. We can also ask the software to find a maximum location for this surface. Remember, when we created the design, the response had a goal associated to maximize, and that manifests itself through this desirability function. And if I come to the hotspot, I can say maximize the desirability function, and it finds the location where we have a maximum, which is about 0.88 for X1 and 0.77 for X2, and the corresponding response value is 2278. If we come back to the contour plot, that represents the region up here. In fact, let's just check those numbers more closely. So 0.88 for X1, 0.77 for X2. So let's put those numbers in, 0.88 and 0.77. So you can see there the current Y value 2278, and you can see that location being shown with these crosshairs. So we've seen three different ways in which we can visualize the response surface. We can look at it as a surface plot, we can look at it as a contour plot, and we can look at it using the profiler.